Okay, hi, my name is Will, and today I'll be going over the rainbow window demo. And in this demo, you will be able to see continuous absorption and emission spectra. So when astronomers look at a star with no dust in the way, you can see a continuous spectra of light. That's because the star emits light of all frequencies. And so you can see red light, green light, blue light, ultraviolet, all the different frequencies of light you can see. But as that light interacts with, say, like a field of dust, then if you look past the dust to the star, then you can see what's called an absorption spectra, and that's basically different atoms and molecules in the dust cloud absorbing specific frequencies of light. And then what they do is they re-emit that light in all different directions. So if you look, for instance, perpendicular, so I'm not looking at the star, but now I'm looking at the dust cloud, you see what's called an emission spectra, and you have these very distinct sort of spikes in light, and those are the emission lines. So now I'll be going over the specific lamps of the rainbow window demo, excuse me. And so these four on the bottom here are like elemental lamps. And so this first one here is hydrogen, and if I do that, and the next one here is helium, and this is a mercury lamp. And then finally we have a neon lamp. And so in each of these lamps you can see the distinct emission lines because these are purely elemental lamps. And so they are emitting frequencies of light at those very specific bands. And that is due to lots of complicated quantum phenomena. But it's really cool. And then I have a few other lamps here that sort of serve as a control, so you can see what an ordinary light bulb would look like under these special lenses. And so here I just have a normal incandescent bulb, which will emit a continuous spectra. And then here I have an LED light bulb, which also emits a continuous spectra. And these are just the ordinary incandescent and LED lights that you would find in your home like normal. So these two light bulbs are really cool. This one serves as our demonstration of an absorption spectra. So when you look at the spectra, you can see those absorption lines that I was talking about if you look through the dust cloud at the star. And then we have our last two bulbs are not so much demonstrations of absorption, emission, or continuous spectra, more so they show a little bit more special properties that spectroscopy has. So for instance, this lamp right here, if you look through your lens, as I slowly increase the brightness of this bulb, you start to see more of the spectra fill out. And so you get to see more of the red light and the blue light and the green light, and so the spectra starts to fill out the more light that it emits. And then finally we have a bunch of different colored LED bulbs here. And what's really cool about these is that they sort of demonstrate the refraction of the lenses that you're looking at in order to separate this light. And so different frequencies of light get refracted through the lenses at different angles, and so that's how you see the different frequencies, or the different colors rather, separate from each other. And so this is simply a bunch of different LED bulbs colored from blue to red, and if you look through your lens you can start to see that they get refracted at different levels, and so they start to form sort of stairs as you go up. And so that's a really cool demonstration of how the lens affects light.